Hello everyone, in this video, I will go through the advanced information for further maths. Before I start, I want to emphasize two things. Firstly, topics that are not appeared in this PDF can still appear in the real exam, so make sure you revise everything properly. Secondly, bullet points in this PDF are not in question order. That means you need to revise all types of questions, not just the particular type of question satisfy the bullet point. Okay, let's start. In this Excel sheet, there are 3 columns. The first column includes all the bullet points for COPU 1 and 2. The second column is topics. You can see I have filtered all these bullet points by topics. And the third column would be some explanation I will go through in this video. Make it slightly bigger. All right, so let's start from the first one, which is the matrices. First bullet point, matrices inverse of a 3 by 3 matrix, singular and non-singular. So when you revise, you should also know the transpose matrix, because in some algebraic proof, they will have transpose matrix there. And then you should know the axioms of matrices. Okay, the first one is matrix commutative in terms of if you have matrix A multiply a matrix B, that's not equal to matrix B multiply matrix A. However, if you have matrix A plus a matrix B, and that's the same as matrix B plus a matrix A. Distributive, so matrix A bracket B plus C is equal to A multiply B plus A multiplied by C. And associative, that would be matrix A plus bracket B plus C bracket is the same as bracket A plus B bracket plus C. Okay, so the axioms of matrices, you should know that. Second one, proof by induction with matrices. There are other proof by inductions you should also be aware of and practice, but the main focus would be with matrices. Use matrices to represent the linear transformation in 2D. So that includes, change a different color. That include 2D rotation, reflection, and enlargement. Okay, so you should know the area scale factor and the linear scale factor for enlargement. So knowing that determinant is the area scale factor, and the linear scale factor would be the constant you have in front of the matrix. Although the invariant point and invariant line are not mentioned in the advanced information, but you should also be aware of it, knowing how to find them in case it appears. Third bullet point, I highlight it when I finish. The third bullet point, matrices, solution of 3 simultaneous equations. Firstly, you should know the geometric significance. They may ask you, okay? There are different type, maybe formed in a prism, or 3 can be 3 plane intersect at a unique point, or can be 2 plane parallel and the third plane going through them. So we need to be able to describe it. And this one can be linked to vector. So they can ask you, I give you three equations of the equation of three planes, and I say apply a transformation matrix on them, and after the transformation matrix, how would that look like? Yes. Okay. Next bullet point. Improper integral and hyperbolic functions. So this one I labeled as under improper integrals, and that's under further calculus. So the improper integrals, you can see here, I have listed potentially all kinds of improper integrals. So that could be one infinite limit. For example, I can have integral 5 to infinity. So that's only one infinite limit, or both infinite limits, which means integrating from infinity to infinity. And sometimes I have both limits being numbers, but then because the expression itself is a fraction, the denominator need to satisfy x can't be certain values. Then for that could be using improper integral. And the next one would be convergency and divergency. So you need to know that although, for example, most classic example is if I'm integrating from -2 to 1 over x dx. Okay, so if you do that, if you don't break at 0, so if you're integrating from -2 to 2, the answer just being 0, and you think that's finite. But actually, if you draw the graph, you can see it. And the graph is not continuous at x equal to 0. So you have to consider the convergency divergency from parts. So you can say from the first part, left side, if you find this improper integral, that goes to infinity, which is diverged. If partially diverged, then the whole thing would be diverged. Okay, so therefore we wouldn't be able to calculate it. We can only say this is diverged. Okay. Links to mean of functions. So in MATHAS Math, there are a lot of questions, quite good. The first part using improper integral, finding the answer, and the second part then use means of functions to calculate the mean. For mean of functions, you need to be aware of this one. You need to be aware of transformation. Can have vertical transformation and horizontal transformation. So how would them affect the mean value of the function? You need to know that. Right. So next one would be integration and partial fractions. So this one, I think the most classic example would be I give you a fraction, you need to split into two partial fractions. One integral is in ln, the other one would be inverse trig or inverse hyperbolic function. So for example, let me think about the example. So for example, if I have integrating 3 plus on 4x, and the denominator being the square root of x squared minus 9 dx, I will be able to split it into two fractions. So one would be 3 over the square root of x squared minus 9 plus and you can see here the first one, okay, the answer would be 3 cos x over 3. So that's hyperbolic functions. And the second one will just be 4 bracket x squared minus 9 to the power of a half. And then don't forget your plus c. So this is the kind of question I would think that could link in partial fractions, integration, and hyperbolic functions. Okay, so I'll leave it there. Now we come back to the bullet points. Next one would be the, yes, so can you differentiate inverse trig? Do you know the proof? I think very likely they will ask you part A to prove it, the derivative of inverse trig functions, and then part B, use it. So know the proof is quite important. The next bullet point would be still inverse hyperbolic, So this is knowing the proof of finding the derivative of inverse trig. Okay, previously, that's inverse trig. Now, let's move on to inverse hyperbolic functions. So like I said, it definitely involves calculus. And can you draw the graph of inverse hyperbolic functions? They can ask you to do graph transformation. All right, and you should also know the graph of non-regular hyperbolic functions and their exponential forms. Although it's not mentioned, but I think there will be certain questions asked you to prove using exponential form of the hyperbolic functions. So make sure you practice. Next one, differentiation of hyperbolic functions, Maclaurin series. Yes, so this is quite standard, just approximate values. Next one, Taylor series, limits, and L'Hopital rules. So this one would be ask you to finding the limit either using L'Hopital rules or Taylor series. And you should know that for L'Hopital rule, there are only two forms, either 0 over 0 or infinity over infinity. For other indeterminate forms, for example, 1 to the power of infinity. So those different kinds, you need to be able to either using exponential to convert it into the normal L'Hopital forms and then apply L'Hopitals. So that would be quite important. Okay. Next one, solution of first order differential equations. We have learned two methods, separate variables. Oh, sorry, this is misspelling here. Okay, variables, misspelling here. Or integrating factors. This is quite standard. Solution of second order non-homogeneous differential equations. Yes, so require you to know both homogeneous and non-homogeneous. You need to know that when the particular integral is in the same form as the solution of the complementary function, then you need to raise the power of x. Okay, so if before it's just x, then you need to use x squared. Yes, and another type can link with Taylor series. So I would draw an arrow from here to here. I can use Taylor series to approximate the answer of differential equations. The next one is reducible differential equations using substitution. Yes. So same thing, you need to do some practice on this one. Followed by T formula. Bear in mind these can link with calculus. Next one, coordinate system. They have ellipse, hyperbola, rectangular, hyperbola. So you can see a no parabola. So parabola is not mentioned here. And for this topic, I wouldn't say this topic, the concept is not hard. I think the hard part is you carry all the unknowns and do geometry. So that's the hard part. If you have trouble with that, then you maybe revise these topics with coordinate geometry, circle geometry, and vectors, because those are linking to geometry. So knowing focus directrix property, they can also ask you to find loci. For example, I have an ellipse, okay, and then I need 2 points, and I ask you the center of these 2 points, so P and Q, can ask you to find the loci of the midpoint of PQ. So those kind of questions. Let's move on to next one. Algebraic inequality and inequalities including the modulus sign. Yes. So for the modulus one, very likely you will use graph. Make it slightly bigger. Using graphs to find the intersection that require, and then finding the required region. Very important thing is you need to know how to use the set notation. Some students lost mark because they don't know how to use set notation last time. So from now you need to make sure how to use it. All right, followed by numerical solutions. Really not much to say about numerical solutions. 3 different methods, you need to know them. Next one, vectors. You can see there are 3 bullet points for vectors. So for vectors, mainly you know the links between points, lines, and plane, okay? Do you know how to find the distance from a point to a line, from a point to a plane? Find the distance between line and plane. Knowing the relationship between lines can have intersection, can be skewed, can be paralleled. And the relationship between planes can be parallel, can be intersection. Okay? Angles, can you find the angle between a line and a plane and between 2 planes? For plane and lines, there are different type of equations. Can be vector equations, can be Cartesian equations, can just using scalar product, can also using the dot product. Okay, they can also ask you to follow the reflection point. So I have a plane, I have a point P. Can you find the reflection point of P in the plane pi? So that's that. It can link to matrices. That's what I mentioned before, okay? So if I give you the equation of pi being something, and I say, okay, now transfer it in the transformation matrix, let's say T equals to something, and would you be able to find the equation of pi after the transformation? So you need to know this. Vector product, yes, the product that could link to finding volume and finding area, although it's not written in this advanced information. Next one, the vector equation of a plane. Yes, you should know that using dot product or cross product. Next topic is complex number. So there are 1, 2, 3, 4, 5 bullet points from complex number. You can see how important it is. So complex number, the first one from CP1, you need to know the multiplication, division, and conjugates. Then links with rules of polynomial equations, Argand diagram. So for this one, would you be able to use the formula used in rules of polynomial to finding unknown A, B, or C? So you should also know the rules of unity. Okay, so if the nth root of unity is basically a rotation of a vector by an angle theta each time. So which means if I have 5 roots of unity, then w plus on w squared plus on w cubic from plus on w to the power 4 plus on w to the power 5, all of them add up, the sum of them would equal to 1. Can you link with polar coordinates? So, and Cartesian equations. So I give you the complex number, for the Argand diagram, right? I can write as a complex number. I can also ask you to write the Cartesian equation, for example, a circle. And it can also link with polar coordinates. It's very rare, but it could happen. So I'm going to show you a question for this. One is sample paper, Copil 2. So there's a question. This question 6. So I give you as complex number Argand diagram. You can see that. But then for the part II, they ask you, this locus of points can also represented by polar coordinates, a polar curve with this equation. So would you be able to write in that form? Yeah, so have a look at this question. Question 6, CP2 paper sample, Edexcel sample papers. So that's this. And finding the region use inequality, same thing. You need to be able to use a set notation. So that's that. Next one, de Moivre theory and with volume of revolution. So firstly, this is in CP2 complex number. You can link with sequence and series. You should know, do some practice. They can ask you to find cos nx or cos x to the power of n. So these two are quite classic. You should do some practice. Linking with volume of revolution here, I'm going to use a different color. Orange. Volume of revolution, I haven't seen a question like this, but I think it may look like same paper, CP2. I'm just going to use the questions 4 here. So you can see, for this question is complex number question, okay? So part A, part B. Then for part C, I can throw a part for volume of revolution. So if I ask you, say, for y equals to cos theta square, I will ask you to find the volume of revolution in x-axis. That's literally, you can't basically integrating cos theta to the power 4 directly. But from part B, you have basically write it as the right hand side, and therefore you can then integrate it. So from part B to part C, I would think if they put these two topics, that would be how it looks like. Okay, so yes, have a look, and when you finish, let's go back to the advanced information. Okay, so next one would be still complex number, addition and multiplication, division. Yes, this belongs to the CP2 now. So you just knowing how to apply the exponential form, okay? So that's that. Then complex number, same thing, CP2 addition, subtraction, simple loci in the Argand diagram. Yes. Move on. Polar coordinates. Polar coordinates tend to be a difficult topics for students. Personally, I think you just need some practice knowing the tangent, horizontal tangent, what does that represent? Which means my gradient is 0, that means dy over d theta is 0. But when you have vertical, that means my gradient is undefined, which means dx over d theta is equal to 0. Okay? And finding the areas. Yes, I think you need practice. People know it, really know it. People don't know it. Seems like they lack of understanding on everything. Yes. So ask your teacher if you need practice with polar coordinates. The final one, next one is relationship between roots and coefficients of polynomials. So you need to know the variation. For example, if I ask you to find 1 over alpha plus 1 over beta plus 1 over gamma, where alpha, beta, gamma is the root for a cubic equation. You need to rearrange it and find the answer. Next one, methods of difference for summation of infinite series, right? You need to know the summation for r squared and r cubic. For method of difference, when you just need to see the difference of the denominator. If the denominator have a difference of 1, then you will keep the first element and the last element in the sequence. If the difference of the denominator is 2, then you eventually will keep the first 2 terms and the last 2 terms. Okay, so there's a pattern there. Make sure you understand and know how to do it. Okay, so this is the end of copy 1 and 2 and further P1. I'm going to pause for 30 seconds and then move on to further mechanics 1. All right. Now for further mechanics 1, it's basically everything. Let's look at the first one, impulse in 1 dimension and 2 dimension. You should be fine. I think most people are fine with that. Power and work energy. Similarly, I think is quite a reasonable topic. It may be on the inclined plane, so you just need to be careful with the angles. So energy, so the gravitational potential energy and elastic potential energy, that's internal energy, internal force. Gravitational force and elastic force would be the internal force. Therefore, we treat them as energy within the system. However, the work produced by external forces count as work. For example, the external force can be the pushing force, can be air resistance, and so on and so forth. Next one, Hooke's law. So Hooke's law is an interesting topic for sure. So you could have horizontal spring, okay? So for the horizontal spring, that was my spring. So natural length, that's where the center of oscillation. I could have horizontal string. Horizontal string, that means it's a string linking to a particle, and the center of oscillation would be here, okay? So when the string being stretched, then you are doing the oscillation. When the string is not being stretched, then you are moving with constant speed. So this part is oscillation, and then let's say you start from here to here, that's oscillation. From here, go back to there, that's moving with constant speed. And then you go to the other side, also moving with constant speed until the string being stretched again, then you're doing the oscillation. Okay, so that's that. You then have horizontal two springs. So that could be, I have a spring 1, I have another spring here, and the particle is connected here. Both strings have different have different lambda 1 and lambda 2. So these kind of questions. Then followed by inclined plane, you need to vary for the angles here for inclined plane. Then you can also have vertical spring and vertical string. So for the vertical one, just be careful when you hang it naturally. The center of oscillation is not at the natural length. So let's say this is the natural length, but it's not there. It's here. So this is your center of oscillation, because naturally when you put a particle on the spring would be extended to compensate the gravity, okay? So always be careful with the center. Yes, so that's Hooke's law. Then we move on to successive direct impact. These can be two particles, can be one particle with a wall, can be two particles with a wall. And also for the E, because E is a range from 0 to 1, when E is equal to 0, what does that imply? That means when particle A and particle B collide, they merge, become one particle. When E equals to 1, that's perfect elastic collision. The perfect collision, that means speed of separation is the same as difference of speed of approach. Yes. Oblique impacts of two spheres. So you can have two particles given 1D information or 2D information. What do I mean by 1D information? For 1D information, that means I give you the, maybe black is not a good color. Maybe choose a different color. Maybe red, okay? So 1D information, that means I give you speed. I give you the speed and angle of approach, okay? And for 2D information, I use black. That's different color. For the 2D information, that means I give you as a vector. So speed of approach just being a vector. What else can we have? We can have one particle with a horizontal wall and vertical wall, okay? So that's relatively simple. The hardest one is the one particle with an angled wall that require you to use a scalar product. What do I mean by that? So if I have a particle coming in, okay, I have a U being something, and let's say this particle is going to hit a wall. That wall is neither horizontal or vertical. I can say the direction of the wall, I'm going to use D to represent. The direction of the wall can be, let's say 1, 2. So for, okay, maybe this is now right, looks like perpendicular. So I go in this way. Let's do, I'm too misleading, going this way, yeah? Okay, so for this kind of question, do you know how to do it? You still need to find the component parallel and perpendicular using product rule. Okay. Not product. Sorry. I mean cross product of vectors. Sorry, not cross product. Actually, dot product. Use dot product to find the components of U in the direction of D. Yes. Sorry. Dot product. Finally, is the successive oblique impact. So that would be quite similar to normal oblique impact, but now you have either 3 particles or you have 2 particles with a horizontal wall. So I haven't seen successive oblique impact involving 2 particles with a non-horizontal or non-vertical wall. I think that would be too difficult. So far I haven't seen a question like that. So I think we will be okay with it. Right, so this is the end. Yes, I will be sharing this Excel sheet on Firefly, so you'll be able to download and use it for your own revision purpose. So finally, thank you for watching it. If you have any questions, or if you think there are some things I missed, then please feel free to come to me and speak to me. Have a good day.